All right, friends, it's that time again. Time for homework. So this is lesson 6-7 homework, and I'm going to go through the answers with you. I'm not going to solve every single problem, but I'm going to get you at least started. All right, so problem 1. Based on the past musical productions, a theater predicts selling 400 minus 8p tickets when each ticket sold is P dollars. That makes the input P dollars, okay? And the output is going to be our revenue. Complete the table to find out how many tickets the theater expects to sell and what revenue is expected to receive at the given ticket price. All right, so let's go ahead and go over here. I'm going to do a few of these so that you have an idea of how we're doing it, all right? So I came over to the whiteboard, I copied and pasted this. So our first one, our number of tickets is going to be 400. I spend all of my life messing with this font size, I swear. All right, let's try that again. So it's going to be 400 minus 8 times 5. 8 times 5 is 40. That's 400 minus 40. I checked that. Did that math just now. So that equals 360 tickets sold. I'm going to go a little bit into the next row just so you're not terrified. Revenue. How do we get revenue? Revenue is always the price that you sell them for times how many you sell, right? However many you sell. So in our case, our revenue is going to be, so for this line, revenue is going to be, we sold them at $5 times 360 tickets. Right? And that equals, I will grab a calculator. Actually, I'll just do it with you. We'll go up here. We'll go to my scientific calculator. 360 tickets sold at $5 a piece is $1,800. So if we came over here, the number of tickets that we sell, let's put it in a text box. The number of tickets is going to be 360. The revenue that we're going to get from this is going to be $1,800. Let's pick one more random one just in the middle. So we'll pick 20 just for the sake of picking 20. So that's going to be 400 minus 8 times 20. 8 times 2 is 16. Out of 0 is 160. So that's going to be 400. So I'll put an equal sign. 400 minus 160, which equals 240. Yep, 240. I'm sticking with it. I'm sort of scooting this over so you can see where I got it. And then our revenue is going to be 240 times $8, right? The $20. The price that we sold it for, however many we sold. So if we come over here and we have 240 tickets sold, if we want to check our math just to make sure that we did that all right, by the way, that's going to be 400 times parentheses 8 times 20. It's 400 minus 240, okay? So then we're going to have $20, and we're going to multiply it by 240 tickets, and we're going to get 4,800. So our revenue for this one is going to be 4,800, right? So when we go to P, the equation for how many tickets is going to be 400 minus 8p. You, by the way, need to fill out the rest of this in your own table, right? This equation right here is going to tell us how many tickets sold. How many sold? And then our revenue should be the price multiplied by how many sold. How many sold? So for an equation, we're going to have P is the price times 400 minus 8p. So this is going to be our equation. That is going to be our revenue. If we want, we can add in an equal sign, equals revenue. So the question is, for which ticket price will the theater earn no revenue? So we know that when we want to earn no revenue, well, we don't want to earn no revenue, but we know that we're looking for when revenue equals 0, that's going to be called the zeros. The easiest way to find this is we're just going to go graph it. Let's go graph it. Let's go ahead and go to my graphing calculator. So we have x times 400 minus 8x. Notice I switched to x just because it's easier. It's simpler for the computer to know what to do. I'm going to zoom way out. So I see that my next line is going to be at 50. So if I look at it, I see that I'm going to make 0. I'm going to cross this line. Y is going to be 0 at 0, which makes sense. And then y is going to be 0 at 50. So the answer is going to be the zeros, the points where we don't get any revenue, is going to be at, so that's at $0 and at $50. If we make the price too high, nobody buys it. At what ticket price should the theater sell the tickets if it must earn at least $3,200 in revenue to break even? All right, so we want to say, what value for x does y equal 3,200? So this is our question. What is the answer here? I'm going to go ahead and turn this black, see if I can make it easier to see. I want it in a blue, but I want it in a blue that you can actually see. It's okay. All right, so let's go back to our graph and let's make an equation. Let's say y equals 3,200. Sorry, 3,000, yeah, 3,200. All right, so obviously we're going to need to crazy zoom out. So we know that we're not going to have negative prices, so we can actually just start. The x-axis is going to be at 0. This doesn't need to be any more than 50, so we'll sell this 52, right? So it's at 50. We are not going to try to find out what any kind of negative revenue is, so we'll make that at 0. And then we need to go at least 3,000, so let's go 6,000. All right, so what we have here is we made a line at where we need to be. So what we need to be is we need to have this portion. This is the portion, anything on this line is the portion where it's going to be greater than 3,200. This is our 3,200 line. So that means that at our smallest x value, it's going to be 10. We're going to keep going up, 10, 11. I'm just trying to slide along here, right? We can see it 11. We can see it 12, 13. It's going to peak at 25, and we're going to come down. And when it hits this number, which is 40. So anything between 10 and 40 is going to be enough to earn money back. So any price between 10 and 40 will break even. All right, so that's our answer for question 1. It's a little bit of a complicated question, and it feels like it's one of the most detailed one of the questions. All right, so let's look at problem 2. Problem 2, a company sells running shoes. If the price of a pair of shoes is $P and the company estimates it will be this many pairs of shoes, write an expression that represents the revenue of dollars from selling running shoes if a pair is priced at $P. So we already know how to do this. This is actually pretty easy, and we know what to do. So we're going to say that revenue is equal to the price that we set it at times how many you sell, right? So in this case, our price, so our revenue is equal to, the price is set at P, and then we're multiplying it by, this is the amount of shoes that we will sell. So it's 50,000 minus 400P, right? All right, let's look at problem 3. The function F represents the revenue. Again, revenue is the output. In dollars, the school will receive if it sells this many coffee mugs. Here's our graph. Select all the statements that describe this situation. So we're selecting statements. So I'm going to go ahead and switch over to a pen so I can mark it off. So A, at $2 per coffee mug, the revenue will be $196. All right, so if we input at 2, so let's see, if we input at 2, we're going to go up, and we're going to hit about $400 as our revenue. So A is definitely not right. I'm going to go ahead and get rid of these lines. Now that you've seen it in the video, I'm selecting these lines and it didn't work. I'm getting rid of these lines so that it didn't work either. I don't understand why it's not working. All right, well, either way, I can rewrite this. So A is going to be a not happening. All right, B, let's look at B. The school expects to sell 160 mugs if the price is $5. Well, let's look at the thing. At $5, so here's our $5. We're going to go all the way up. Here's our number, right? Well, we could actually put that's going to tell us what our revenue is. So our revenue is going to be 800. But instead of doing that, let's actually put the math into the calculator, or let's calculate it out. So we have, if you are going to sell them for $5, you're going to have 220 minus 12x. And instead of x, we're going to put in $5. I'm not enjoying that. Okay, let's take off this. All right, I got rid of the little circle thing. All right, so let's go ahead and let's go back to my calculator. I'll just go really fast back to my calculator here so we can put it in. So we have 220 minus 12 times 5. 12 times 5, close parentheses, equals 160. So what was the answer? It expects to sell 160, so this is a big yes. So B is definitely yes. All right, the school will lose money if it sells mugs for more than $10 each. All right, well, let's see where $10 is. $10 goes right here. Will the school lose money? Nope. All of this is still a profit. So that's going to be a nope. The school will earn about $1,000 if its school sells mugs for $10 each. Let's see, $10 hitting right at about 1,000. Yes. So this is a yes. So D is yes. The revenue will be more than 700 if the price is between $4 and $4. Let's see. Between 4 and 14. Yeah, I agree with that. Those look like that's where the 700 line hits. Okay, I'm going to take that off so I can make sure to get it. So I agree with E still being right. F, the expected revenue will increase if the price is greater than $10. All right, so we have our $10 mark. Nope, it is not increasing. The revenue is not increasing at that point. It is decreasing. It is still revenue. It is still positive, but it is not increasing. All right, let's look at problem 4. Write an equation to represent the relationship between n step numbers and the number of squares y. So our answer is going to be, our output is y equals math and n. All right, describe how each part of it. So when I look at this, I can see right away that it is not linear, right? We are not adding the same amount each time. This is 8. 2 times 4 is 8. 8 times 4 is 24. This is not 24. All right, so that means I know for sure that it's going to be quadratic. So then what I do when I have a pattern, and you know this, is I go ahead and I am going to mark out the quadratic. So I see 1, I have 2 times 2 is 4. 3 times 3 is 6. Sorry, 3 times 3 is 9. All right, and what do I see at the top? Well, actually, to be honest, I see the same thing. So each one of these is double the amount of quadratic, right? I've got 3 times 3 twice. I've got 2 times 2 twice. I've got 1 times 1 twice. So I know that it's going to be n squared. So I know that it's going to be n squared, but there's 2 of them, so I'm going to have 2 times n squared. Is the relationship between the step number and the number of smaller steps quadratic? Yes. How do you know? Pick one of the many reasons how we know. All right, problem 5, technology required. A small marshmallow is launched straight up in the air with a slingshot. Here's our function, all right, to describe the height of the marshmallow. Let's graph h and find when it reaches its maximum height. So 5 plus 20t minus 5t squared. Let's do this. Y equals 5 plus 20t minus 5t squared. That doesn't sound right. That sounds like I messed that up. Nope, it is right. 5 both. Okay, well, it is down there. So let's go ahead and shrink let's go back down to 50. All right, it's still way too big. So let's go ahead. It looks like 5 is the maximum. So let's go ahead and stretch it out to 5. All right, that looks a lot better. So our marshmallow is flung up to the top. It's going to hit the highest point. The highest point is at 2 seconds. Remember that this is our time. Our time is our input. Our output is our height. So it's going to hit 2 seconds. And at 2 seconds, it's going to be at the maximum height, which is 25 meters, I believe. I believe meters is what it was. So using graphing, we did that. You could add a picture if you wanted. When does the marshmallow meet? When does the marshmallow reach its maximum height? The answer is 2 seconds. How long does it take for the marshmallow to hit the ground? That's going to be at the 0. That's when y equals 0. So let's look. When was y equals 0? It equals 0 at 4.236 or 4. We can round. We can write it. It's only 4 numbers, right? So when does it hit the ground? Let me add a text box. So it's going to hit the ground at 4.23, was it 4 seconds? Let me check that. 6 seconds. We wouldn't want that thousandth place to be off. Right? What domain makes sense? So what makes sense? Well, we know that anything before times 0 doesn't make sense. So anything from 0 until it hits the ground. And it hits the ground at 236. So it hits the ground. So what is the reasonable domain? The reasonable domain is from takeoff to landing, which you should know is from 0 seconds until 4.236 seconds. All right, a rock is dropped from a bridge over a river. Which graph could represent the distance fallen in feet as the time, as a function of the time in seconds? Okay, so before we even look at any of these parts, let's think about what that means. So we're representing the distance fallen. So as you fall, I'm going to write this in a text box in case you can't hear me. As you fall, you increase your distance fallen, right? If you fall for 1 second, maybe you fall 16 feet. If you fall, I can't spell feet, apparently. If you fall for 2 seconds, maybe you fall 60 feet, right? As you fall, you increase it. So anything that's decreasing, like this, is not going to be right. I'm going to get a thicker marker so that you know that I'm the one writing on there. So this is not going to be right. And this is not going to be right. That leaves us with this one and this one. Based on what we know that falling, right? We already know falling is a quadratic function, right? Oh my goodness. Falling is a quadratic function. You are accelerating due to gravity. Acceleration due to gravity is a quadratic function, so we are pretty sure that no matter how much we wish it was that one, it is not going to be this one either. That leaves just graph C. Oh, sorry, you could have circled there. So just graph C. All right, we made it to the end. That wasn't too bad. I hope this video helped. I hope you listened all the way to the end, and if you need to play it again because you didn't understand something, I hope you are able to do that, okay? Have a great rest of your homework.